Hello everyone, and welcome to today's webinar, Data Integrity and Connectivity for Lab Balances. I'm Kaylee Bach of LabRoots, and I will be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Sartorius. To learn more, visit sartorius.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. I'd like to now welcome our speaker, Sebastian Weber, Global Product Manager, Software Solutions at Sartorius. And joining us for our live Q&A session today is Peter Hickey, Manager of Application Specialists for Lab Weighing at Sartorius. Sebastian, you may now begin your presentation.
Hello everyone, welcome to our presentation about data integrity and connectivity for lab instrument. Let me briefly introduce you myself. My name is Sebastian Weber. I'm product manager at Sartorius Lab Instruments in Germany, and I'm delighted to be here today to talk about 30 minutes how data integrity problems can be prevented in the lab and what are the connectivity requirements for a modern lab instrument. The presentation today is interesting for different stakeholders. When it comes to the purchasing of a new laboratory instrument, there are different interests. I think the most important is that the instrument produce trusted results, but we have also the laboratory staff who need an instrument that is easy to use, supports them in their daily work, and increase the overall efficiency in the laboratory. On the other side is QA, which must ensure that all compliance requirements are met. Especially here, it is important that an instrument supports compliance without slowing down the user in their daily work. And another important player today is the IT department. For them, the focus is on ensuring that the tool can be easily integrated into existing and future IT environments, meets all the IT security standards, and does not require a high level of support or operational maintenance. As you can see, the requirements for a modern laboratory instruments are high, especially when it comes to an essential laboratory instrument such as the balance, which is used in many different areas like production or QA. I would like to start with a brief introduction to the topic of data integrity, and after that I show examples from FDA warning letters of different data integrity violations and how these can be prevented by using a modern laboratory instrument. So why is data integrity so important? All of our decisions, like a batch release, are based on information and results from our daily laboratory work. And if we have incorrect data or incorrect information, these lead us to wrong decisions. And if we make wrong decisions, that increase the risk of compromising our product safety and quality. And we know if the product has not the safety and quality what it should have, it can have negative impact on the product cost and, more important, on our patient's health and the patient safety. And at the end, this breaks the trust between our patients, inspectors, and stakeholders. And also, we lose our brand reputation, and therefore, it is so important that we make the right decision based on the right data. So, what is data integrity? With data integrity, we want to cover two major goals. The first one is we want to ensure that the data is recorded exactly as intended or observed. On the other hand, we want also to ensure that the data remains the same as when it was originally recorded, and this over the entire data lifecycle. And we know a data lifecycle in a GXP environment can be 20 to 30 years based on the different regulations. And these principles of data integrity doesn't come up with computerized systems. We have to follow the same principles also when we work handwritten or create handwritten records. But what we will see in the next slide is that when we work electronically and with computerized system, we can increase the efficiency and the reliability of our data. Yeah, how important the topic of data integrity is, we can also see from the listed violations in FDA warning letters, where data integrity issues featured in more than 65% of all letters in 2019. This shows us, on one hand, that the topic data integrity is strongly in the audit focus of different authorities, and on the other hand, also how different the violations are. So this can be, for example, that an SOP was not followed or simply no SOP exists. The data was not transferred completely or correctly. And here also remember this can be related to digital records, but also to manual data transfer, for example, to a lab notebook. Or another very common topic is everything around the audit trail. For example, the instrument did not have an audit trail, the audit trail was deactivated, or simply the audit trail entries were not reviewed. I will show examples of this later, and also how digitalization and a modern laboratory instrument effectively prevent these issues. You should also always keep in mind that data integrity is not only relevant for electronic data. Paper-based records are also subject to the same requirements, but often a good and well-planned digital approach is safer and more efficient in the everyday laboratory life. So, how can we prevent this? First of all, organizations should follow good documentation practice to assure the completeness, consistency, and reliability of the records, and therefore follow the ALCOA principles. What are these ALCOA principles? Yeah, first of all, the A is for attributable. That means the record contains all metadata like username, instrument, and timestamp, and not only a pH or weighing value without any information around. Then our record or our data must be legible, or also known as traceable. That means the data is readable, understandable, and can be fully reconstructed by people who are reviewing the record. Our data must also be recorded at the time as it was generated or observed. And especially here we can see how digitalization and connected system help, as typically in these kind of systems, the value is stored immediately electronically by the system, and does not require a manual data transfer. The data must also be original. Original data means in this context the first capture of the result or the information, and this data must be signed, reviewed, and readable over the entire retention period, which can be in a GXP environment 20 to 30 years. Therefore, you should use standardized data formats instead of vendor-specific whenever it's possible, where the data can also be read in future, maybe after a change of an operating system. Last but not least, our data must be accurate. That means that the data is correct, complete, and reliable. This includes on one hand that the system, like the balance or the limbs that is generating the data, is qualified, and the validated state and the data itself are regularly reviewed. But also that if, for example, errors are found in the record, the error and the correction of the error is documented cleanly with the reason, the timestamp of the correction, and the signature of the person who have correct the record. So when you buy a new laboratory instrument, you should make sure that the instrument has all the technical features to support you in implementing the data integrity requirements. What are these features? First of all, the instrument should have a comprehensive audit trail. It should provide you a user management with personalized user accounts, an electronic signature function. Very useful is also a time synchronization feature. It should have a backup functionality, and it should provide different interfaces and protocols for the safe data transfer of the results into another software system like LIMS or ELN. In the next slide, I will show you how you can use these different features to prevent data integrity issues, and I will do this with examples from our Cubis 2 balance. The Cubis 2 balance from Sartorius provides all these features without the need of any additional PC-based software. This makes it very easily for you to integrate the balance directly into your LIMS or ELN system, and it reduces also the validation and maintenance costs at the end. Our first example from an FDA-1 letters shows why user management and personalized user accounts are so important. In this case, an analyst worked with a common user account or shared user account, so it was not longer possible to track who generated the data or made changes to the system settings. Therefore, each user should work with their own personalized user account. It should be a unique account, and the instrument must have functionalities to prevent this account from being used by other users. This includes complex passwords, locking the account after too many wrong logins, or even the automatic logout after inactivity. Especially with an essential laboratory instrument, such like a balance or a pH meter, which is present several times in the laboratory, a central administration of the users is very helpful, so that the users do not have to manage on each instrument. In the optimal case, this is a direct integration of the instrument into the corporate domain or Active Directory, without any additional software in between. This is, for example, possible with the Cubis 2 via LDAP protocol, and this makes the handling easiest for user, as they do not have to remember passwords for different laboratory systems. They can log on with their Windows account password, and it also makes the administration simpler and faster. Another example from the same warning letter is that the users not only used a shared account, this account has also administrative right that allow changing the date and time on the system, or maybe also other system settings through which manipulations were possible. Therefore, the system should have a role management in addition to the user management, so that the users only have the rights that they need for their daily laboratory work and do not have the possibility to change critical system parameters as a normal laboratory technician. Role management should be also customizable so that the roles and the linked rights can be adapted to your company needs and to the related SOPs. This example shows also another important point, the importance of the correct time. With modern network devices and instruments, it should not longer be necessary to change the time manually on the system. An automatic time synchronization can ensure that the time on the instrument always be correct. This is especially important for simple embedded systems since the time he can drift away after 1 or 2 months. Yeah, problems with the audit trail, like you can read in this warning letters, can often be found. Here, an audit trail was not activated, or it was possible to deactivate the audit trail, and therefore it was not possible to detect changes in the system, such as changing the time or deleting data. And this again lead to data integrity violations. Therefore, you should always buy a laboratory instrument that has an audit trail, and in the best case, it should not be able to switch off the audit trail to prevent the problem. However, it is also important that the audit trail is regularly checked for violations and also to ensure that the instrument is still in a validated state. And therefore, the audit trail should be easy to understand. You should have an option to export the audit trail for a review on a PC, because you don't want to do this directly on the instrument. And yeah, also a sort and filter function could be very helpful to find specific entries inside the audit trail. Yes, I think the next violation is clear to understand. The records were not signed and therefore not assignable to an individuum. And this can be prevented very easily if the system is forcing electronic signatures before a record is created. Together with very strict passwords and personalized user account, you have then a very proof and clear assignment to each record. This warning letter contains two important statements related to data handling of a standalone instrument. On one hand, it was possible to delete data like audit trail, and on the other hand, the data could not be restored because no backup was created. With a reliable instrument in a regulated environment, it should not be possible to delete data on the instrument under normal conditions. Data that is not correct, for example, because something was weighed in incorrectly, should only be marked as invalid together with a reason, but never deleted, so that everything remains traceable. Even if the data cannot be deleted by a user, data loss can always happen due to hardware defects, and therefore an instrument should have a backup functionality, and the backup should be performed in a regular way. With our Cubis 2 balance, we have solved it very simply and safely. The backup is automatically transferred to a server in the network at the preset time interval, and so no user action is necessary for this procedure. We also recommend that the file formats are chosen for archiving the data are also still readable in 30 years and therefore are not vendor specific. An accepted file format in the pharmaceutical industry is a PDF format. Additional security can be provided by generating a checksum of the PDF file. The checksum can be used later to verify that the PDF has not been manipulated and is still the original one. Another problem, especially with the balance, is the attention of the measurement uncertainties. As we know, every measured value is subject to an uncertainty, which can affect our results or our experiment. Especially very small sample weights are subject to very large relative uncertainties, and therefore you should not perform any weighing below the minimum sample weight. But also the measurements above has uncertainties, which have to be known to interpret the results correctly. A modern instrument can support you in this by providing workflow support for the determination of the working range, prevent weighing below the minimum sample weight, and also display and document the measurement uncertainty of each measured value. And all these helps you to get very trustable results for your experiment. So now our last FDA warning letter, and as you can see from this, it is also always important that the system status is monitored to ensure compliant operation. In this case here, no attention was paid to the fact if there were network or power interruption during operation, which could also lead to incorrect data or results. A laboratory instrument or system should therefore indicate the system status and warn if necessary. With the Cubis 2 balance, for example, we have centralized this in a status center that clearly shows the user the system status of the balance, and in the event of problems, it provides also support how to resolve the problem. Furthermore, you can block the balance when it's out of specification, for example, not level, that you only make measurements inside the specification. I hope these examples have shown you how different the violations can be and how modern laboratory instruments such as the Cubis 2 balance can prevent these issues. The laboratory instrument itself can only support through its functions. The organization itself must always ensure the compliance operation. And it is therefore always important to identify the GXP relevant processes, data, and system, and to do a risk assessment based on this. Then you should create SOPs and train your users on the SOPs and on proper data handling. Also, regular audits should be performed and the qualified conditions of the system should be ensured. Altogether, with an open quality culture can prevent problems through data integrity violations. Beside data integrity itself, which also refers to paper-based data, the second focus on the presentation is on the connectivity, which makes processes and data exchange more secure and more efficient. I think all of you know that digitalization makes our processes faster and more efficient, and at the end, the data more secure and reliable. Therefore, there has been a lot of talk about the Digital Lab 4.0 and technologies such as Internet of Things, big data, cloud computing, or blockchain. I don't want to dive too deep into these topics. The most important is for this all the instruments, processes, and data are linked together, and we need laboratory instruments that fits perfectly in this environment and support us in our digitalization strategy. But when we take a look in the laboratories today, we don't see this high level of integration. I think most of the laboratories are working still with these printouts when it comes to essential laboratory instruments like laboratory balance or a pH meter. And here you have the problem, is this digitalization when you have handwritten signatures and correction? And how will you bring these data into your LIMS or ELN system at the end? When the instrument is maybe directly connected to the LIMS or ELN, then we see mostly only two scenarios. One is you have a serial cable and integrate the instrument via the serial interface. But here's the big question, is this a safe data transfer via serial connection and includes the serial transfer all the required metadata, or is it still, for example, the weighing value? Yeah, when you have maybe a deeper integration, then you have quite often some kind of converter or middleware in between the instrument and the lab system. so that the instrument is only connected to these vendor-specific software, and then the software is integrated into the lab system. But the big question is here why you have this kind of software, because the software only increase the complexity of your setup. You have much more effort when it comes to validation and IT maintenance, and at the end it increase your costs, because on one hand of the more effort of the complexity and validation, and on the other hand you have much more IT maintenance costs for the extra software and so on. Yeah, to make it better than in the slides before, you need some kind of digital and compliant documentation workflow to work 100% paperless. And how can this look like? I would like to show you on an example with the Sartorius Cubis 2 balance, where we have implement these kind of workflow directly on the balance. First of all, you need a feature that you can review results before you create a report. This can be done on the Cubis 2 directly on the balance, and when you see some kind of error inside your results and you want to redo the test, you don't have to print it out, then use your pen, cross the value, and make some handwritten comments and signatures on it. You can do this directly on the balance and flag the result as invalid and write your comment directly on the balance touch screen. So when you have reviewed your results and make your corrections, then you can directly sign it on the balance with your electronic signature as creator. This is very useful for you because you don't have to go to the PC. It can be directly signed on the balance screen, and then you can continue directly your work without switching between PC and the balance. And after you have signed it with your electronic signature, you will create a full compliant record with all the required metadata, and you have several possibilities now with the Cubis 2 balance to generate these reports and to transfer it to different systems. And yeah, what are the possibilities here? With Cubis 2, we offer future-proof options for integrating the balance into different systems. We know that not every company already has the possibility to integrate equipment directly into a laboratory software, or it is even a LIMS or ELN still not in place. On the other hand, many companies are planning to implement the balance in the next few years and do not want to buy a new balance right away when the system is live. Therefore, Cubis 2 grows with your digitalization requirements. So today you can use digital documentation workflow, as I shown before in the slide, but still work with a normal lab printer. So you still have a paper-based solution, but instead of handwritten signatures or crossing out invalid entries, you can do everything electronically directly on the balance. When the balance is on the network, the paper-based entries can also be turned into PDF files that are sent to a file share or a document management system. And this is the first step to going completely paperless, but still compliant. Yeah, and when you later want to integrate the Cubis 2 balance directly into your LIMS or ELN system, also here the Cubis 2 has different possibilities for full compliant integration over network without the need for any additional hardware or converter or software in between. So I think the simplest way, what is also supported by most of the LIMS or ELN systems, is that you create an ASCII file directly on the balance, for example, a CSV file, and transfer it to a file share where the file is read in or passed in by the software system. And this is very easy to implement, I think, on both sides. It's a standard feature of the Cubis, but also on the LIMS side. And the other case is what we support with the balance, to make a direct connection to a database server, for example, a Microsoft SQL server, to store data or read data from this database server. And also we support REST web services. This is also an interface what can be used by many software systems to communicate with the balance, to read data from the balance, and to send data to the balance. And the REST web service interface allows also a deep bidirectional and seamless integration of the balance over the network into some software system, and I will now show you with two examples how it works. Yeah, as I said, I would like to show you now how the full integration of the balance can look like into different laboratory systems. And we create these both examples together with partners, and it shows you not only how a paperless and deep integrated solution works, it shows you also how these solutions can help you to increase the efficiency in the laboratory and be compliant with the common regulations. Yeah, first I would like to show you the integration of the Cubis 2 balance into Omnis, Metrum's titration platform, to make the process more efficient and safer. Here we follow a plug-and-play integration which is based on web services and complies with all IT security standards such as the encrypted communication, and it makes the integration very simple. The solution is of course fully 21 Part 11 and EU Annex 11 compliant. The user management and audit trail storage is done centrally in Omnis. And yeah, how does it work in detail? Yeah, the biggest advantage is that all weighing related steps can be performed directly on the touch screen of the Cubis 2 balance without having a computer next to it. This saves space and you can concentrate fully on the sample. The weighing process can also be initiated directly at the balance. As you can see on the left screen, you can select the rack position for the sample directly on the screen, and then you will guide it step by step through the weighing process. During weighing, all relevant information, for example, the sample name or the method, is displayed on the screen, and at the end, the weights are saved directly in Omnis with all required metadata. Another advantage of the integration is that the user can use different Omnis systems with only one balance. It is not only a one-to-one relationship as it's known, for example, with simple RS-232 connections where each balance is linked to only one system exclusive. I think this solution, what we have done together with Metrum, shows how different vendors can link system together over IT standards very easily and provide their customers a very efficient and safe solution. Yeah, another good example for a deep integration via standard interface is a seamless integration in a LIMS, here together with Starlims from Abbott Informatics. The goal of this integration was to design a LIMS balance integration based on web services that is on one hand easy to set up, but also fully compliant with the highest standards of data integrity and IT security. The modern web service-based technology allows us to design something that is much better than the traditional way of setting up these balanced LIMS connection via RS-232 or file transfer. The entire preparation, such as the assignment of the sample ID to the sample or the selection of the method, is done inside the Starlims. The entire weighing process can now be executed directly on the balance without the need for a computer beside the balance. Perfectly, the samples then have an electronic readable sample ID for example, a barcode or an RFID code, so that this ID can be read directly with a scanner that is connected to the balance. Of course, it would also be possible to enter a sample ID via the balance touchscreen, but this brings the risk of errors. After that, the balance checks if all conditions or specifications are fulfilled, so that the balance is calibrated. The user who is logged in is allowed to work with this kind of sample or method, and also if it's the right balance type for the sample. The user is then guided step by step through the weighing process, and all relevant sample informations are displayed on the sample screen. And at the end, the results are transferred back to the LIMS together with all the required metadata. Such a paperless and compliant integration not only prevents data integrity violation, it also increases efficiency in the laboratory with the direct integration, and you save additional operational costs that would be generated by a middleware software or a converter between the LIMS and the balance. I think here we show together with Abbott Informatics how an integration from an instrument into a LIMS in the future should look like. Yeah, that brings us to the end of the final section. I hope I could show you with these examples the possibility of integrating the Cubis 2 balance into different software systems and how this can achieve maximum compliance, lower IT costs, and higher efficiency in the laboratory. Please feel free to contact us or visit our website for more information about the Cubis 2 balance or the integration solutions with our partners. Yeah, at the end, I can only say thank you all very much for taking the time to listen to this presentation. I hope this has given you an insight into the problems of data integrity and connectivity of laboratory instruments and how these can be solved with a modern instrument like the Cubis 2 balance. I'm very happy to receive your questions, and thank you and have a nice day.
Thank you, Sebastian, for your informative presentation. Joining me now is Peter Hickey as we begin the live Q&A session. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen. We'll answer as many questions as we have time for. All right, let's get started. Our first question here asks, what technical controls are on the Cubis 2 balance to ensure full 21 CFR Part 11 compliance?
Hi. Okay, so on the 21 CFR compliance technical controls, on the Cubis balance, what we have here is we have the user management, we have the audit trail and the alibi memory. We also have got the safe data transfer process, plus the backup ability, and just finishing with time synchronization. And also we have the facility to have e-signatures. Now, these technical controls for the Cubis 2 balance are all on the balance. There isn't a requirement to have external software to do this, because I know there are systems, other products that, they will cover all of that, but they will require the use of an external software pack. So just to highlight, these technical controls that I've listed, and they're all very much part of the whole 21 CFR compliance requirements to give you the Alcoa principle data, but they're all on the balance. Yeah, and it's quite a powerful system, and it's been very, very well received. I'm hoping I've covered everything on that. If there's any qualification needed on it, please feel free to put another question in the box.
Great, thank you, Peter. This next question asks, How can I make sure that the PDF documents have not been manipulated?
Okay, right. So that's an interesting one. Yes, so anytime you send data to a a source, you're sending data to another location, it's always going to generate a checksum file or an MD5 file, which is basically a file generated algorithm. So that will always follow the data. So if you're sending data to the server, it'll go with the MD5. The LIMS system will have the file generated algorithm in place. So basically, you always have that security that the data is always accompanied with a checksum. So that means you can check that the data is as per the original data that went out from the balance. So it's a checksum system.
Great, thank you. All right, this next question asks, how many users can be created on the balance?
Okay. So to be honest with you, there isn't actually a limit of the number of users to be created on the balance. Now, obviously, the facility to have it corporate directory, active directory control on the balance does help with this. But I know that we have done tests in our R&D labs where we have had up to 10,000 users on a balance. So there is no restriction really on the numbers of users on the balance. And as I say, because it helps because it's all centrally controlled with regard to that. So no limit.
Great. All right. Next question here. What happens if the connection to the file share does not work? Will the data be deleted?
Okay. So if the connection to the file share is interrupted for whatever reason, it will generate an error message. Yeah. And you will be given options. You can retry, you can redirect, or you can cancel. But the data will not be deleted. And the data will be saved into the ring memory of the balance until this connection is actually remade. So from that perspective, it's quite secure.
Great. All right, this next question has a few parts to it. It starts out, what is the current expected durability of the touchscreen panel, especially if multiple samples are weighed or screen touch activity? Chances of decrease in sensitivity or ghost touches are common in touchscreen?
Okay, well, yes, I mean, I know that the touchscreen technology has moved on very, very dramatically, especially in the last sort of 2 years. I know that when we developed the Cubis 2 2 years ago, we basically went with the high-end options where we're using this TFT display. It is very much designed for, lots of repeated use. It needs to be able to withstand that type of extensive activity on the balance. So we haven't seen that. We haven't seen any issues with the touchscreen. As I say, it's been developed with that in mind.
Great, thank you. Looks like we have time for a few more questions here. This next one, what are the weight ranges of the balance models?
Okay, the weight ranges. So in the Cubis 2 range, we go from sort of 7-digit high resolution balances, so that micro balances and ultra micro balances. So they would start at a capacity of 2.1 grams and really down to 7 digits. And then you go right up to the sort of large scale, high capacity precision balances, which would be, our cutoff currently would be 70 kilos. Our balances tend to end up in both the lab, but also the production. And I think it's always a very good thing when the users are using the same sort of functionality and the same interfacing as they're using in the lab or in the production environment or in the scale-up, pilot scale lab, that type of thing. So as I say, 2.1 grams at the high resolution end, microbalance, up to 70 kilos on the high capacity precision balance.
Wonderful, thank you. This next question asks, how much results can be saved? Will I have memory full?
Okay, so basically the results that are saved are the results we use a process called alibi data. So every time we generate data, there is a copy of the data on the balance, which is the alibi data. But we don't store other results on the balance. We basically give you a preview of your results, and then you decide what to do with it. Now, with regard to the alibi data filling up, yes, it is storage on a system. It will eventually fill up, but it is quite a high memory of available ring memory on the balance for alibi data. You're typically talking, depending on the use of the balance, it could be 4 to 6 years before it actually overwrites old data. But you always have the facility to back up and to import your alibi data, and you always will be pre-warned that it's about to overwrite old data. But there will not be any data loss.
Great, thank you. Looks like we have time for one more question here. Is there a specific software to make user login to the balances?
Okay, so the balance uses the Cubis software, if you like. So that's the balance software. This is where the user and application management is set up. So that's basically on the balance. And then depending on how you want to connect to the balance, a lot of people are using their own corporate Active Directory LDAP facility. So this in conjunction with the balance functionality to manage profiles and to set roles for various profiles. So essentially all of that functionality is on balance.
Great. And we actually have time for one more question in here, so we'll ask this one. Once a balance has been validated, can other balances be configured the same remotely if on a shared network?
Once a balance has been validated, can other balances be configured the same remotely if on a shared? Well, it is possible to match up settings with regard to balances. So it is possible actually to clone balances with regard to the setup. I'm assuming that's what's meant by this question here. But it's so from that perspective, yes, you can do that.
Great, thank you. Well, thank you again, Sebastian and Peter, for your time today and your important research. We would also like to thank LabRoots and our sponsor, Sartorius, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today, and those submitted during the on-demand period, will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, take care, everyone. Goodbye.